So in this video we will see about implementation of dynamic memory allocation in C. So in the last video we covered about the basic concept of dynamic memory allocation, what is dynamic memory allocation and how the dynamic memory can be allocated using malloc function. So in this video I will give you the simple C program for this dynamic memory allocation. So in this C program, we are not going to use the entire structure of a C program. So just we have we have only two parts. First one is that preprocessor directives and then a main function. So in the preprocessor directive, so we can include so any number of header files to our programs. So header files that are the files which contains the predefined function. So in this program, so what are the predefined functions that are required is the predefined functions related to getting input and so printing output to the user, and then predefined functions for dynamic memory allocation. So the predefined functions for getting input from the user and displaying output to the user are scanf and printf functions. So these two functions are available in stdio.h, and in the for dynamic memory allocation we need the main function is malloc function, and to implement that malloc function we also need a size of function to get the size of a particular data type. So these two functions are available in std_lib. So initially I have include these two header files, and I have so define a function, main function. So now inside the main function I need to write the code for creating dynamic memory. So in the last video the dynamic memory can be allocated using malloc function. So the same malloc, this is the function we need to use. So just recall the malloc function that takes one argument. The argument is nothing but the size of the memory block that need to be created. So in this program, this is a simple program. I am going to create a dynamic memory for storing one integer value and another dynamic memory for storing one float value. So for creating a block for storing a integer value, so the malloc function should takes the one argument, that is the size in bytes, to store a integer value. So how to get the size of a integer? So for that we need to use a size of function. So the size of function takes one argument. So in that argument we get to specify the variable, or otherwise directly we can able to specify the data type. So here we are going to specify the data type integer. So and then this malloc function returns a value. That value is a address. So that address should be stored in one pointer. And since this is a memory block created for integer value, so this memory address should be stored in a integer pointer, just like pt. And so typecasting. So this memory address that is returned by this should cache to the type integer pointer. So I typecast this. So in this line I'm just implement malloc function to create a memory block to store a integer value, and the same way I am creating another memory block, a dynamic memory block for storing a float value. The same thing. So malloc. So here the argument is size of float. So and then the memory address returned by this malloc function should be stored in a float pointer. So I am creating another pointer variable ptr1, and then the memory address should be typecast to a float pointer. Okay. So now I created two memory blocks, and then I need to store values to the memory blocks. So how to access this memory block? So by using that pointers. So by using pointers only we can able to access the memory block. That means we can able to store any value on that memory block by using that pointer, as well as if you retrieve a value from that memory block only by using the pointers. So now I'm going to get a value from the user to store in the pointer ptr. So for getting a value for a for getting an integer value, so in C program we use a scanf function. So the scanf function take two arguments. So first one is we need to specify which type of value that we are going to get by using this scanf function. So for that we need to specify a format specifier. So here in this scanf function we are going to get a integer value. So for getting the integer value, the format specifier is %d. So and then we need to pass the address of the variable or address of the memory in which that value is going to be stored. So in this example I am getting a integer value, and that value is, we need to store that value in this particular memory block created by this malloc function. So as I already told you, in the scanf function we need to pass the address. So in a C program, if you get a value that to be stored in a variable, so in this case we use that ampersand symbol. After that we will specify the variable name. So that ampersand symbol is used to get the address of any variable. But here that variable is a pointer variable. That ptr is a pointer variable. So as I already told you, so that value, the memory block can be accessed only through that pointer variable. So since the ptr itself stores the address of the memory block, here we need not to use that ampersand symbol. So just giving that ptr itself, it returns the address of that memory block where that input to be stored. So and then next I need to get value for the floating point. That means the floating point value to store it in the next memory block. So here also we need to use that same scanf function. So first we need to specify the type, what type of value we are going to get. So here I am going to get a floating point value. So the format specifier is %f. So and next we need to pass the address of the memory where that this value to be stored. So since the address is stored in the pointer variable ptr1, we just give that pointer variable name itself. No need to use that ampersand symbol. Okay. Now I get value from the user to store it in the memory block. Now I am going to retrieve the values that are stored in the memory block. I am not going to do any processing on that values. Just I get that value and store that value in the memory block, and I am going to retrieve that value and I am going to print it. So for that, for printing a variable, we use printf statement. So you know the actual syntax of the printer statement, whatever value that need to be printed, we got to give within a double quote. So whatever that you are returning inside the double quote, that string will be printed. And if you want to print any value, so in that particular position, like in the scanf, we need to specify the format, which type of value that we are going to print. So here what I am going to print is, I am going to print like this: the value stored in the address, some address is that value. Suppose if the address is 4000, for the integer value I am going to store the value 10 and address is 4000, means it should be printed like this: the value that is stored in the address 4000 is 10. So how to print it? So here the value that is stored in this is a constant, and after that we give some value 4000. That 4000 is the value that is the value that is stored in the variable pointer. After that it is a constant, and we need to print 10. The 10 is the value that is stored in the address 4000. Okay. So how to print it means, the constant just within double quotation we got to print that, we got to just type the constant, the value stored in the address. So after that we need to print the address of that is stored in the variable ptr. Okay. So now we cannot print like this ptr. If you will print ptr, then it just print ptr, it won't print the value that is stored in the variable ptr. So for that we need to the same thing. In scanf we specify the format. So here also for any variable, so to print value of any variable we need to use the format specifier. So here I am going to store the value stored in the pointer variable ptr. So for pointer variable, format specifier we need to use is %u, and then is. After that we need to print the value, a integer value which is stored in the memory block, that is pointed by the variable ptr. So here I am just going to print a integer value. So %d, double quote it. So actually while executing this program, So your compiler will print like this. The value stored in the address, it will be printed as same. And instead of percentage u, it won't print percentage u, so it will be replaced by some value that is stored in the pointer variable that we are going to specify after this double quotation, a separator, comma, separator, and then it will just print yes. After that, it is going to print a integer value that we are specifying in this printf statement. So first, in this percentage u, we are going to print the value that is stored in the variable ptr. So I'm just give ptr. So and then in the percentage d, what I need to print is the value that is stored in this memory block. Okay. So in this memory block, we only know the address. So that address is stored in this variable ptr. If I print ptr, it just print the actual address of this memory block. But I need to print the value stored in this memory block. So how to retrieve it? So same ptr, and before that variable name I need to give asterisk. Okay. So in this printf statement, I am printing ptr and asterisk ptr. So since this is a ptr is a pointer, if you just print ptr, it will print whatever value that is stored in that variable ptr. So in the variable ptr, what value is stored? The address, the starting address of this memory block. So that address will be printed. So instead of this percentage u, it will print the address which that is stored in the variable ptr, and the star ptr. So ptr is a pointer. So before that ptr, if you give asterisk symbol, that means it will not print what is the value that is stored in the ptr. It will take the value stored in the ptr as a memory address. For example, if this is 4000, means it takes 4000 as a memory address and will go and retrieve the value which is stored in that memory address. So in that memory address, we store some value. The one value we are getting in this particular line. So that value will be printed. So in the same way, I'm going to print the second floating float value. So here also same thing. The value stored in the address percentage u is here. I am going to print a floating point value. So here percentage f, but the percentage u is same because in this place I am going to print a address. But here, since that floating value is stored in the memory block created in this step, this second step, and the address of that memory block is stored in ptr1. So here I need to print ptr1, and in order to get the value that is stored in that malloc function, I need to use star ptr1. So after printing each line, I am going to use percentage n slash n for new line. Also I am going to use slash n after the percentage d, so that the input will be prompted in the next line. Okay. So this is the end of our program. The end line, since this is the this function, main function is declared with the return type of integer, we need to return one integer value. So I'm just return 0. Okay. So this is our program for implementing dynamic memory allocation. Now we will see how this program works. So return RETURN. So just I'm giving a value 10, and next I am giving a value 20.5. Now just see the output. I hope this is visible. So first enter the value of integer, I give 10, and enter the value of float, I give 20.5. Then it prints like this. The value stored in the address. So this address, so that first malloc function, we create a own malloc function. So that malloc function create a memory block, and the address of the memory block is this. And in the memory block, I stored that value 10. So it prints the value stored in the address is 10. And next it prints the value stored in the address. So this is the address of the memory block created by this malloc function. So and then it prints the actual value 20.5 that is stored in that memory block. So this is the way how you can implement that malloc function for creating a dynamic memory. Now, so in the linked list, so this is a simple method to create a memory block. That this memory block we are just can able to store one value. So for in the first malloc function, we can able to store only one integer value. In the second malloc function, that memory block created by the malloc function, we can store only one float value. But if you so go through my linked list video, so you can understand that in linked list each element is represented as node, and in the each node, apart from a value, the address of the next element should also be stored. So in linked list, for each node, we need to create a memory, dynamic memory. But in that dynamic memory block, we are not going to store a single value. For example, if it is a list of integer values, we are not going to store a single integer value. So in that memory block, along with that integer value, we need to store the address also. So how to create such memory? So in a single memory, different type of values to be stored. That is the main difficulty or main difference in linked list. So I hope everyone knows structure. Structure is a user defined data type that is supported in C. So in a linked list, we are going to create dynamic memory for the user defined data type structure. So here I'm creating dynamic memory block for primitive data type integer. Here I am creating a dynamic memory block for primitive data type float. So in this memory block I just can able to store one integer value. And so in this memory block I can just store one float value. Suppose if you use the same malloc function to store for a structure, for a user defined data type structure, we can so in the structure we can, a single structure we can able to store a different kind of data. So if you create a dynamic memory block using malloc for a structured variable, then in that memory block we can able to store different kind of values. Okay, so in the next video we will see how the malloc function can be used to create a memory block for storing different kind of data using structure. Okay, thank you.